In the last video, we discussed the lineages of different kinds of dinosaurs, but to keep things more concise, in that video the sauropods were more of a footnote. I'd like to address that now by giving the sauropod dinosaurs their own time in the spotlight. Previously, we learned that the ancestor to sauropods and theropods was closer to theropods in appearance, being bipedal with a slender body and possessing clawed digits on its hands. However, we did not learn how this dinosaur became some of the largest animals to ever walk on land. To find out, let's take a look at how the body plan of these dinosaurs changed between the clades Sauropodomorpha and the first true sauropods. One well-accepted theory as to how sauropodomorphs were able to grow so big is the appearance of tachymetabolic endothermy in these animals, which means they had transitioned to being warm-blooded. It is difficult to fully explain why sauropods' body plans changed so drastically, but one theory is that as the animals' weight distribution changed, as they developed a larger chest, forelimbs, and neck, it slowly became more necessary for them to walk on four legs, as their center of gravity moved further from the pelvis. The time at which these animals had fully transitioned to walking quadrupedally is where we mark the cutoff point between sauropodomorphs and true sauropods. That's not all to the story though, of course, because what really makes sauropods stand out is their large size and their long necks. Aside from warm-bloodedness and a high oxygen content in the atmosphere, there are much bigger reasons why sauropods got so big, perhaps the most important of which being a feedback loop between the large size of their body and the small size of their head. Let me explain. Having a large body uses a ton of energy. Even just using their legs to transport their enormous bodies was incredibly taxing for very large sauropods. That's where the long neck comes in. Instead of spending too much of their energy walking, the long necks of sauropods allowed them to reach a large amount of vegetation while standing in one place. And it's not just the tops of trees that these animals fed on, as has been popularized in media. Many sauropods are believed to have fed on ferns and grasses in a side-to-side sweeping motion like a prehistoric weed whacker. However, supporting such long necks was not easy. To be able to pull it off, sauropods had extremely tiny heads for their body size, a high number of neck vertebrae, and fairly weak chewing muscles to aid in the digestion of heavy fibrous plant matter, which meant that the body had to get bigger in order to fit a gut that was equipped to break down that vegetation. Because of these two factors, sauropods' bodies kept getting bigger, their necks getting longer, and their heads getting smaller. This is generally how the body plan of sauropods developed throughout the late Triassic, but there is a great diversity among sauropods, so let's take a look at how they diverged until the end of the Cretaceous. The first branch we see is divided between Eusauropoda and animals such as Volcanodon and Spinophorosaurus. Typical of sauropod development, Eusauropods were larger than the basal sauropods, with longer necks and smaller heads. Next, Neosauropoda branched, separating itself from sauropods like Shunosaurus, Rapasaurus, Patagosaurus, and the species in Mamenchisauridae. Originating in the early Jurassic, Neosauropods quickly became the dominant large herbivores on land, until the appearance of titanosaurs in the Cretaceous period. Within Neosauropoda is what I think is the most interesting branch in sauropods. In the late Jurassic, we saw the branching of Neosauropoda into Diplodocoidea and Macronaria. Let's start by taking a look at Diplodocoidea. Diplodocoidea branched into Rabacosauridae, Dichrosauridae, and Diplodocidae. Dichrosauridae included sauropods with impressive spines on the backs of their necks, such as Amargasaurus. Diplodocidae includes many famous sauropods such as Apatosaurus and Brontosaurus, which are both in the subfamily Apatosaurinae and roamed what is now North America, as well as sauropods such as Diplodocus. The other group, Macronaria, included the Titanosaurs and Titanosauroidea, and Brachiosauridae, which include sauropods like Brachiosaurus and Giraffatitan, which did primarily feed on treetops, unlike most other sauropods. Sauropods were a widespread and successful group of animals, but of course as we know they all died out at the end of the Cretaceous during the KPG extinction event. There is a lot we still don't know about how sauropods lived, but they will continue to capture our imaginations and our hearts forever. Thanks for watching, and I hope you have a good one. Until next time, see ya.